Do that. Okay. Well, I'll get started since it's time. Welcome to the August 12th, 2025 session of TAPR and HamSCI technical session. My name is Dave, KV0S, and this week been dealing with organizational things and a few health things and that kind of stuff, but I've been reorganizing my shack a little bit too. So, and learning more about some of the new versions of Debian. So that's it for me. Next on the list is Dave. Are you ready to
Yeah, I
talk?
can.
Okay. He
Yeah,
was he
I
was working on something, so
no,
go
no.
ahead.
I've been making this thing to put it in front of my face to allow the magnetometer subsystem to be plugged directly into a, a a Linux or Windows or even a Mac, I suppose, in theory. Um, and it's working fine. And I spent most the last few days just assembling and testing things. And I've got more code to write, but that's it for me.
Okay. Next on the list, we have David H. W6OQ. Go ahead, David.
Yeah, hi, good evening, everybody. As usual, I'm just here to see what I can learn. Thanks.
Okay. Next on the list is David Julian, WB9YIG. Go ahead.
Good morning or good evening. Not much going on here. I got the WSJT cooked up for the meteor scatter. Uh,
Oh, good.
I got a few contacts today. So other than that, that's all.
Very good. Next on the list is Jay Schwartz, WB8SBI. Go ahead, Jay.
Okay, let me turn get everything turned on here. Howdy, everybody. Well, um, last week, a handful of us were over at K3LR's, Tim Duffy, in the just inside the state of Pennsylvania from the Ohio line. He's only literally a very short distance, few miles, if that, from the Ohio-Pennsylvania line on Interstate 80. He's got an incredible, and that's the only way to describe it, a totally incredible station set up there. He's got a grand total, sit down for this one, of 52 antennas, all hardline fed. Most of them are Foursquare, in Foursquare configurations, monoband Foursquare configurations for the HF band. All of them have hardline feed, uh, and all those Foursquares, they're monobanders. Uh, his attention to detail of the entire system, the antennas from nose to tail, the feed lines, the supporting guy wires, the shack, the station itself, is just an incredible attention to detail. And it's just super impressive. Um, the shack itself is not very big in terms of square footage wise, maybe 12 by 12 feet, something like that. It's not very big. It is cramped, and it's underground too. It's in a what was probably, when his house was first built, a cellar of some kind. That Excuse me, a little bit of sinus there. Was probably some kind of a cellar originally when the house was first built. Um, but the rest of the house is up to date and modern. He also, across the street from him, owns a couple houses which he uses as guest bedrooms for contest. The tallest tower is 262 feet, and he has stacked phased beams for 10 through 40. I even think he's got some 80 meters on there. And when I say stacked, they're like on 20 meters and 10, 20 and 10, 15, 20. They're like four on the various towers. They're not all on one tower, but they're on various towers. But the spacing between them is quarter wavelength spacing. So you have it's like a gain antenna. You not only have the gain of the beam, the Yagi beam antenna itself, but now when they're spaced like this and they're pointed in the same direction, you have gain going this way, the gain of stacked elements. So in some cases, his sideband output power is 1.5 kilowatts across all bands. So that's what he's squirting up the coax from the shack. Well, now you do the math, and let's say you're going to 4 antennas, and you figure the gain of these antennas. So coming up, you've got 1.5 kilowatts divided by 4 antennas, but now you've got the gain of 4 antennas all pointed in the same direction, and their gain is additive. So you can very easily get an ERP in some cases of 250,000 watts. It's really incredible. He's also got a one. It looks like a tower with no antennas on it, but there is. The tower is the antenna for 160, and the tower itself is insulated from ground. So it comes up, and I forgot how high it is, and then off of that, you've got wires, and it's insulated from ground, so it's a 160 antenna for 160 meters. Um, it's really totally incredible. His station also, on any given band, all the radios, they're all ICOMs, and I forgot what the model is, but it's 100% ICOMs. They're all the same model, and every band has 2 stations. Well, why is that? He uses, during contest time, one station stays on one frequency, period. The other station is hunt and pounce throughout the band. Now, they're all squirting up to the same antenna array, no matter what band it is, 10, 15, 20, etc. So ultimately, both stations are going to the same coax going up to the tower. What happens is the first station, you've got 2 stations. The first person that keys up wins the antenna. It's instantaneous switching. So the first person that keys up on a band, they owned all the band for 20 or 10 or 15, whatever it is. They own all those antennas until they drop back to receive. Then now it's back to, okay, whoever's the next one up and hits the PTT first, they win the antennas. So it takes real close coordination when you got 2 guys and they're sitting next to each other and they're going 24 or 48 hours uh, uh, together. You got to have real good coordination to realize what the other person is doing so that you don't try and capture the antenna when the other person needs it. Um, they operate in, for every band, they operate in teams of 3. So that gives one of them a chance to get some rest. And they cycle through, they rotate through. Um, the radios themselves are never turned off, ever. They're just, the screens are turned off because they're connected to monitors. The monitors get turned off, but their radios are left on 100% of the time. The reason being is because they have crystal ovens in there to stabilize. You don't want temperature fluctuations of the crystal controlled oscillators that are in there, the fundamental crystals. heating up, cooling off, heating up, cooling off. You want them to stay stable at whatever they're going to stabilize that. That's it. He also has, it's like a dozen or more of these ICOM radios in the shack. He has 2 brand new, never used in over 10 years, never used ICOM radios, the same model, that those are emergency spares. He keeps them updated, but they've never been used. So if a radio goes out during the contest, they just take that radio out, drop a spare in, and off they go. Uh, but his antennas are all matched. They have stubs on them to keep
So,
harmonics under control, keep the SWR under control, and his wall is literally, the walls of the shack are literally lined with plaques,
so
contest plaques.
Jay,
Yeah.
we're trying to do a roll call in a reasonable amount of time. So,
All right.
if you want to give more details, you can at the end of the roll call.
All right, I'll just say that we did get the monitor, the magnetometer is in the ground, and if you go k3lr.com:8888, you can monitor it. You can
Okay.
monitor what we did.
Okay, very good. Next on the list is Clint, KA7OEI. Go ahead, Clint. Your mic.
It takes a while to catch up. As I can tell this week, I'm not hanging off a tower at 80 feet.
Yes.
Got the work all done. Bird spikes installed, as you saw, so the antenna is working as it should. The machine over there, though, seems unhappy. It randomly goes down, and we're not sure why. So we have another machine that we have yet to install for the 888, and we'll get that online as soon as we can. Anyway, I don't have anything else.
Okay. Next on the list is Michael Helen, AC0G. Go ahead.
Good evening, everybody. Not much to report this week, but been occupied with family visits and household chores and work. So I haven't been able to get much done radio-wise. Back to that.
Oh, okay. Next on the list is Paul Elliott, the WB6 CXC. Do you want a minute? Your
No,
mic?
I'm good
Yeah.
now. Thanks. Hi,
Okay.
everybody. Sorry, I just got here, so I hope everybody's doing well. Okay, quick status report. I've been basically working on the this time sync stuff, trying to get a transmitter running. Doing mostly coding and playing with software, digital phase awk loops. I've got trying to get my timing synchronization up and to a reasonable level. And it's within a microsecond with probably, well, less than a microsecond peak to peak of phase jitter. So that's good for a start. I can do better, but at this point, I'm going to say that's good enough to proceed with the rest of it. Been talking with Scott about the type of patterns we want to send in addition to just the 1 second BPSK. Gonna try basically what is it? I think a 68.2 hertz chip rate quasi-random pseudo-random pattern, which is basically the GPS satellite course acquisition code. That's well documented in plenty of places. So anyway, moving on that, I just got some stuff in the from JLC show up. Walked in the door with a big box. I think that big box is going to contain the circuit boards for that supercapacitor backup. So if that's true, I'm going to start see if I can put one together and make sure it works the way we hope it does. and I will report back on that. Also, just mechanical stuff. It's annoying. The big black or the medium-sized black box that I've been using, like for the filter combiners and all that, been getting them from Adafruit. And last time I had been able to order in good quantity for a good price, and time to order more. I'm not out yet, but I will be. And no, they don't have them. They didn't know when they're going to get more. Fortunately, I know the vendor of that in China. They're the same guys that I use for the whisper sound enclosure, and also for the tiny blue box that I use for some of my filters and such. So I'm having to make me a whole bunch of the bigger boxes and more of the little blue boxes while they're at it. And the good news is the big block boxes are going to be in Turn Island Systems blue, just like the little tiny ones. So it's not really a custom color. It's their stock navy blue, but that I'm going to say it's mine. So I don't know, that's about it. Sure there's more. And so I guess back to Net, and I'll
Okay.
see what the rest of you guys are up to.
Okay. Next on the list is Phil Karn. Any comment, Phil?
Yeah, hi Dave. Yeah, this week's pretty good. Yeah, I've been working pretty hard lately. Most of it is trying to clean up my shack, trying to reorganize my development system, and also just get stuff off the floor so I have room to work around in there. It's amazing. I do have a picture of my development system rack that I can show later on if anybody's interested. I've been doing a lot of work reorganizing it, especially trying to control the RFI and EMI inside of it. So I can show that later if people are interested.
Very good. And next on the list is Scott Newell, N5TNL.
Hey, this week's buzzword bingo. You ready? Get your cards out. Gold codes, bugs, coherence, match filter, BPSK, GNU radio, PSD, AWGN, SNR. Ended the week more
I know all
confused
those
than I
words.
started.
What's the problem?
Yeah, I think I've got about half of them wrong. I just don't know which half. So I ended the week more confused than I started. So I guess that's progress. And I vote for seeing a picture of Phil Shack. That's it for me. I'm out.
Okay. Next on the list is Tom, N5EG. Go ahead.
Okay, good evening. Oh, yep, got the mic unmuted. Good evening. Can
There
you
you
hear?
go. Yes,
Okay.
now we can.
I've been working on the board. After the roll call here, I've got 3D CAD of the 4-channel receiver board. It's very preliminary right now, but all the parts are on it and haven't yet started routing. I'm just initially in the placement right now. Also installed Debian 13 on a virtual machine. Found a couple of installer boo-boos, but got those cleaned up, and 13 seems to be working. Back to the group.
Yeah, I'm trying to have one machine going with 13 as well. So next on the list, let's get Dave McGaw. That's what you get for just jumping in. David?
Yeah. Well, nothing really new this week, except I am on the trying to get at least monitoring the meteor scatter QSO party, switching between 10 meters and 6 meters. We've got our local, one of our local radio clubs is doing it tonight. The Claremont, New Hampshire Makerspace is on it. And yeah, as for one other thing, I'm trying to still work on this satellite ground station. We have an antenna ordered. Unfortunately, our radio club had an antenna that's essentially exactly what we want, except the wrong end of the band. So we had to order a new one. Not cheap, but we're working on it. And I guess that's about it. Back to Ned.
Okay. And next on the list is Rob Robinette. Go ahead, Rob. Are you there? Mic muted. I guess Rob Robinette's not there. We'll come back to him later. So at this point, we're open for general discussion.
Yeah, sorry for taking up so much bandwidth there
Oh.
earlier.
Well, we're trying to keep the roll call short and kind of a status report. And then after that's done, then there's not a moderator telling who gets to talk.
Yeah. Well, anyway, you guys got the point. So, well, let's
It
hand.
is an impressive facility.
Yeah,
So,
one point I'd like to ask here is, I mean, I'm sure all those stations and antennas are not getting used all the time. We should all it'd be good to put out feelers like, would you be amenable to having those antennas connected to SDRs when they're otherwise not in use? For us.
you can ask him.
Well, didn't Nathaniel just install a K9Q radio there?
I'm not sure.
Well, that'd be good. You can get
Yeah,
these switches that
there is
will
some. Yeah,
switch in an SDR when it's not being transmitted on.
yeah, it's right now.
Well,
you can ask him.
Okay.
I mean,
Well,
it may not make
Nathaniel,
sense for all antennas, like the more directional ones, but for
Right.
some of them, it might.
Right. Now, I do know that they were playing around with an antenna. I don't know which one, and they were listening to, various stations across the bands. I know they were doing that. I don't know the details, and I don't know if they have a KA9Q there, if that's what they were using. I know they were using some kind of a software-defined radio, an SDR of some kind, but I don't know.
It's a complete DAISY system. It includes the 888, one of their vertical antennas, the DXE, and a 888 connected to a B-Link, and it's reporting very
Yes.
well. So it's a complete system. I'm not sure that you would see many more signals from the large directional antennas than you see from that vertical. I mean,
Yeah.
the directional antennas will amplify, probably you get a few more in the direction they're pointing. They probably have a lower angle of radiation, but I don't think you're going to see a whole lot of difference between that's been Uli's experience, ON5KQ. He's done a lot of experiments with directional antennas versus omnis, and the directionals help if you have problems, interference, but not.
Just for everybody's information, Scott posted the link and the call sign to look for in the logs in the chat.
Yeah, it's up on it's recording whispers spots as K3LR. Lots of them. It's up there with George and Nathaniel when Nathaniel was on. All three of them are geographically, within a couple 100 miles of each other, and they all receive just about as many spots. But the K3LR is slightly better.
Okay, cool. I didn't know if it was being done or not. It just seems like an opportunity.
We didn't. I agree. I think it'd be interesting to see what a big band, what you would get from a big high, multi-band or multi-element Yankee pointed at 20-meter Yankee pointed at Europe. I'm sure you get more European spots from that than you'd get from the vertical on the ground.
Yeah, and he's got,
but I don't
on his big tower, he's got 4 20-meter Yagis.
Yeah,
So, but yeah, so it's they're at elevations that mean they're probably have a pretty good pattern down near the horizon. So uh, at those times when the bands are especially when they're marginal, the vertical sitting on the ground is not going to hear those. So that there will be, I think, it will be a very interesting study, I think, to compare the whisper spots to a 24-hour whisper spot, and just look at 20 meters in Europe and compare the vertical against those antennas. If there were a period of time, a 24 hours or longer, a period of time when you could dedicate one of the 20-meter antennas to whisper reception. We just need another, whisper demon grape system there. That wouldn't be hard to supply. I have them. So if someone wants to do that experiment, I'd be happy to supply the hardware and mentor it. But my guess is we'll see maybe 10% more signals. That'd be my guess.
Okay.
And of course the 20-meter pointed at Europe wouldn't see all the other things. So it would actually probably get a total number of spots would be lower than the vertical, but it would have more spots from Europe than the vertical does.
Okay.
That'd be my guess, but it'd be an interesting experiment.
Yeah, I wanted to show a couple of pictures here. If Clint's still around, he can give me some advice on this. This one here. I think this is the method that I've been hearing recommended for how to use ferrites on noisy devices like computers. Run all the cables through and wind them in the same direction so that the thing can become its own RF island. Is this the general idea? I mean, every cable, not just power.
That's how I would do it, but
Yeah.
you can expect up to 20 dB on a good day of reduction.
Well, hey, 20 dB is 20 dB. You know, I'll take
Right,
anything I can get right now.
Yeah, I concur also, Phil.
Yeah.
Yeah, that's how we do it.
So I've been doing this for like all of my computers that I'm putting in there. Basically, anything that I think might be a noisy device, this is what I've been doing. So let me find a picture of what I've actually been up to, since I'm not normally thought of as a hardware guy. Um, let me find it here. Here it is. Let me share this one. There we go. That's what I got now. All rearranged in a nice rack. And you can't see everything, but the two computers, the two nut computers there in the middle are all have their cables set up that way. The Raspberry Pi in the middle is just for testing, so it's not necessarily clean. The QESDR just above the sitting on the switch is brand new. That's a QESDR2. Does anybody know if the external clock on the QESDR2 does anything? It didn't seem to react when I gave it 10 megahertz, and it doesn't seem to be producing. Well, I haven't really seen if it's producing anything. It didn't seem to lock up until I connected a GPS antenna to it.
The external clock on a G is 66.672 megahertz.
Oh, no wonder. So it's kind of useless.
Why is it useless? It's quite
Well,
good.
it's useless to me right now because I have basically
Yes.
10 megahertz available.
Yeah, it won't do you any good for
27.
that.
So
Yeah.
you can see on the top shelf right under the serial generator on the left is a four-way splitter. Behind it's a preamp that eventually will go up to the roof. That's just on a disc cone. I have a stack of AirSpy R2s. There's three of them in a pile. I think that's a mistake. I need to spread them out more. They get hot, especially the one underneath, because there's really no way for the heat to get out. In the middle, not really can't be seen, is a brand new Hydra SDR one, which is kind of just came out of the blue as far as I'm concerned. I just heard about it, ordered from DigiKey, and it came a few days later. It seems to be a clone of the AirSpy R2, but not really. And as I ask around, I get a feeling that whoever was working on the AirSpy kind of had a falling out, and they went and built their own unit, and they don't seem to like each other. So I'm not going to press too much harder. I just am, as a software guy, I'm just going to use whatever hardware I can get. I'm not going to get into, politics of producers and stuff like that. If they have it and it works, I can buy it for a reasonable price. I'll buy it and I'll support it. On the right of that, you can see the Leo Bodnar two output. One's producing 27 megahertz for the RX 888 that's in the back, and the other's going through that Chinese distribution amplifier for 10 megahertz. Is feeding all of the air spies, and a cable going up to my either the signal generator or the spectrum mounts I have on the top. And it turns out every time you use 10 megahertz in anything, that's another opportunity for it to get into your receiver. And without that red cable there, I had actually had it pretty good. I'm hearing 10 megahertz now pretty well. Anytime you hook up anything new, it's going to get out. You got to quiet it down. I do have one of the TAPR distribution amplifiers. I built it. It's sitting on the side. For some reason, I'm using this one. I can't remember. But as I recall, that the TAPR unit has transformer output isolation on all of its outputs. And that seems like a worthy thing to try because when I put 10 megahertz into that spectrum analyzer, it put a lot of hum on its output signals. When I transformer isolated it, that hum seemed to went away. So ground loops are everywhere. God, everywhere. Rob, that computer right next to the Kiwi is Terry. That's the one you've been running on running Whisper Demon on. I'd like to retire that machine and move it to one of the NUCs once I learn how to do it. The switch it's sitting on seems to be relatively quiet. I'm kind of surprised. I don't use any more inputs than I have to. And the uplink stream on the right, as you can see, is fiber. I use fiber whenever I can, but it certainly doesn't do everything. That Icon power supply is powering everything through a 12-volt West Mountain strip in the back. I got ferrites around everything I can find. That power supply, despite being about 40 years old, is actually relatively quiet. Despite being a switcher, it's amazingly quiet. Although, of course, I don't trust it either. I have ferrites around everything. So it's getting cleaner. I'm at that point now where I think I'm going to start going around the neighbors and asking them what kind of compact fluorescent light bulbs they still have going. So anyway, any comments on this? Anything I do to make it cleaner? I'm all ears. No comments. I must be doing it all right, huh? That EMI is a headache, especially on HF.
Yes.
Okay, I got a question.
All right.
As far as running multiple different cables through the same ferrite, I guess I don't see why that wouldn't work well. I mean, you might couple one common ground, one common mode noise from one cable onto another cable, but I can't see how that makes it any worse than running them through each through their own individual ferrite. But that's something I hadn't seen before.
Oh, okay. Well, I think it was Clint's idea, I believed, and so I decided I was going to try it out.
Yeah, I've seen it before for a long time. If you have exactly one in and one out, then it's a no-brainer, right? I mean, but the multiple ones gets a bit more wormy as far as do all conductors produce the same amount of trash equally? And of course, what you're relying on is the fact that everything is equal and opposite ultimately, through when it comes to circulating currents in and out. What I've been known to do though is on the device side of the cables, I've been known to put ferrite before the common ferrite for everything so that you bump up the impedance as high as possible so that the bucking nature of the common mode has a better chance to work. Whether or not that really helps is.
You mean putting an individual ferrite on some or all of the leads and then putting a common ferrite downstream of that?
Right, right.
Okay.
I don't see why the common, well, look, it obviously works and it should work. I don't know if you'd get better results with individual ferrites versus the common, that's all.
This is one of those things where, well, I do know that with a single input and output, running everything through the common can work remarkably well because it has to. I mean, because of physics. the more cables you add, and if they're producing different amounts of shash, then the question arises, will it work as well? But this is one of those things where if I ever had access to a clean RF quiet room again, anechoic chamber again, it might be worth trying. But then again,
anyway, no, that I was just interested to see that.
Right. Now, in the past, I could probably do it to some extent here. One thing that is very instructional, however, is if you making a clamp on, using a clamp on ferrite, but putting maybe a dozen turns as a secondary on it, and
you can
connecting
monitor.
it
Yeah.
to your analyzer for conducted noise. That
Oh, that's an idea.
right. In that case, you could put one conductor through it or all conductors through it, and directly quantify the currents on those wires. I noticed you have what looked like a spectrum analyzer in the rack, perhaps.
That's actually a generator, but I do have a Rigol 815 on the top of the rack, and I've been
Right.
using that too. Yeah.
Right. I mean, it's very possible to quantify that, but the trick of with exactly one conductor in and out on something that generates noise like a power supply, running everything through one common choke can help quite a bit. I mean,
Yeah.
but
Okay.
what I prefer to do if I have room to do so, and enough ferrites, is each individual lead will have a few turns through it on its own, so that before
Yeah.
it gets to that common mode, the impedance is already higher than it otherwise would be.
Yeah.
I
It
mean,
can be frustrating sometimes. You have a big, heavy cable coming out of power supply. You know the rule that going from one turn to two turns, gives you, 4 times the suppression, but you can't do it. The cable's too thick. It's very frustrating.
or you
Good.
get one of those big effing ferrites that are this big,
Yeah.
which they're about about $15 each, I
All right. I
think.
was looking. How big are they?
Oh,
Holy shit. That big?
yeah.
4 inches.
I mean, you
Yeah,
I've
see the
just
ones I'm using, they're big enough, but
I've just got a big box of the clamp on ferrites, and I can put 3 turns of RG58 through it, just
three
barely.
turns is like 10 dB, right? I mean,
Yeah,
well,
it
improvement.
depends. It depends on
Yeah,
what either side is
in
connected
theory,
to and what they
anyway.
look
also
like.
3 squared is 9.
also depends. Like right here, though, this is some of that flat Cat6 Ethernet cable.
Yeah, that winds well.
Right, and but what's not so obvious here is that there's one turn of I think there's one ferrite of 31 and two of 43. So we did this. A friend of mine has a cabin in the middle of freaking nowhere, and he has the bane of existence. You absolutely cannot make him quiet. Is PoE cameras.
Oh, yeah.
I mean, anything power over Ethernet is god awful.
I noticed that.
Because by definition, the power part is not balanced by definition. And the only thing we found that seemed to
Yeah.
work worth a damn is over all of HF is the two different type of ferrite materials. 31 goes away practically above 10 megahertz, and 43 kind of works till through 10 meters. If you really want to get OCD or whatever, then you might even throw some 61 in the mix if you want to go higher.
I haven't really been paying much attention to which mix. I just use one of the general purpose ones because
Right,
I'm
right.
quiet things in both HF and VHF.
Right.
Well, the VHF ones probably don't work that well below 10 megahertz or below, but it depends on the mix. You ought to know what mix you're
Yeah.
getting, though.
Well,
Yeah.
they work fine, except you get too few turns. I mean, if you can get enough turns on 51 or 52 or 61, it works every bit as well as anything else. The problem is the other way around. 31 transitions around 10, 15 megahertz and essentially just falls over.
Yeah.
So if you want to use 31 to knock down stuff at 10 meters, you almost might as well forget it.
If at some point, if you put too many turns through, you're going to get capacitance coupling across.
Yeah.
I don't know what that
which
transition point is, but
which is exactly why there are three toroids separated. I mean, we actually made a text fixture on a workbench with this, and this one I don't think I ever did a blog, but this one is good for like 25 dB across most of HF, and it drops down to, by the time you get to 6 meters, it's only like 15.
Geez, half the weight and space on each shelf is going to be toroid material.
Yep.
I
Yep.
guess so.
Well, yeah. Well, you could also do, well, you could also just put everything in a metal box and pass only the signals in and out.
The problem is,
Effectively,
I think I change everything too much. That's the problem.
yeah. Well, you need the kind of metal box we have at Northern Utah. It has a door on it, and there's some chairs and tables inside. And it was a military comm van. Put it this way: when we shut the door, we lose our cell phones.
Yeah. Well, okay. That's a
So
good thing.
That works.
yes, the cell phone signals aren't very good otherwise, but yeah, when you shut the
Yeah.
door, the cell phones go away. It was some sort of late 60s military whatever, but we also have
This is
bypassing and feed through and everything else on every cable that goes in and out. Although we needed to improve the power a bit.
This is a look down at the RF shelf before I put the signal generator on top of it. You can see the loop amplifier at the lower right that I was asking you questions about. And Paul, there's your amplifier, your
Yeah.
preamp in the middle. And we now know about the problem with the output connector. You've read
Which
my
output connector?
Oh, the output connector of your preamp had a cold solder joint inside.
Okay.
You didn't see my mail about that or my message about that?
I did not. No, they've
Okay.
had problems. I check
It
every single
drove
one,
me
but maybe it was
absolutely
just on
nuts.
the edge.
It drove me nuts because when I would put an ordinary connector on it, it would work fine. When I put a T connector on it, it wouldn't.
Okay,
I
it was
busted two T connectors. I actually ripped them apart, putting too much torque on them because I thought they weren't making contact. And
yeah,
it
no,
turns
it's
out,
probably torquing the
yes,
SMA connector so the pin was either touching or not touching
exactly.
the board.
It was about 30 dB of attenuation. It was flat, it was clean. I couldn't
Oh man,
the analyzer. It was 30 dB of attenuation for what it should be.
I've been relying on my spectrum analyzer and tracking generator to test, but I guess I'll have to use the microscope and visually examine
Well,
those because
I that's what I was doing. I put my tracking generator and the 815 on it. And after it basically failed hard, I put it on there and that's what was happening.
yeah, no, it's a problem I am aware of with their soldering.
Yeah.
The ones that I capture, the ones that don't work, ever.
Hard. Yeah,
But
right.
I
It's a big,
suppose in your case there was enough of a contact.
I
Sorry
thought there was
about that.
something wrong with these T connectors. I mean, and like I said, I wrecked two of them with the torque wrench, torquing out too tight to try to get them to make contact. It was driving me nuts.
Well,
So finally, when I realized what was going on, I took it apart and I fixed it, and I could see that there was really not much solder there. Put it back together, it all works fine now.
yeah,
As you
well,
can
you
see,
needed to get back in touch with your soldering iron anyway, I think.
yeah, I know. Hey, I'm a double E. I know I'm a double E. Um, I put two transformers on there. I don't know if they're really needed. One goes to the RS-888, the other one is going to the Kiwi that I just got. And it seems to work okay. I'm not sure if I need the transformers or not. I think I do need transformers on the 10 megahertz. Like I said, I was seeing a lot of
Yeah.
on my signal generator before I put 10 megahertz on it, or if I just turned off.
Yeah, the TAPR distribution amp does indeed have those transformers, and
Yeah,
mine doesn't. So
I guess that's why they're there. I guess other people run into the same problem.
yeah.
Um,
Hey, I've got something to show if when we get back around to my turn.
okay, sure.
Oh, okay. Okay, this is what was in that box. I don't know if that's going to show up. Okay, this is the capacitor board. Right now I charged it up and the little green light's on because the only thing that's draining that super cap is the LED. If I plug in a 12-volt supply, let's see what happens. Ah, there we go. The charge light goes on. And if you wait long enough, and it shouldn't be too long because it didn't discharge all the way, the red light will dim and the green light will come on, and that'll be that. So the red's charging and the green light is ready, or it's charged as far as it's going to go. So Clint, your design is
So
come together.
I suggested you do the charge and ready different than I did, and I guess you just detect the voltage drop across and turn on the charging light. Then when that goes away, turn on the green.
That's exactly what I did.
Okay.
Yeah.
After I built mine, I thought, duh, that would have been easier to do.
Yeah, and I didn't want to have it be dependent on
voltage,
the actual voltage,
right,
because this thing will work for from 9 to 20 volts, and it won't care. So
right,
I think that's a reasonable approach.
right. Yeah, I mean that's exactly what I should have done. After I built the second one and got it installed, I thought, I could have made this better if I just made it simpler.
Yeah, no, we keep throwing stuff away and simplifying it, and it gets better and better. The
And-
only problem with this board is this connector here. God, I hate these tiny connectors. The polarity was wrong.
Oh,
Really couldn't tell which way they're going to be mounted, and it's just, trust me, it's not obvious from any of the drawings or specs. So I had to hack away the well, you won't see it, but I had to hack away the shrouding around the
Oh, yeah.
connector while we were talking, so I could plug in upside down. But having done that, it actually works. So I'm very, very pleased with this.
Hey,
And
Paul, I wanted to see the schematic to this thing. Do you have it up somewhere?
Yeah, you guys carry on your conversation and I'll bring it up and show you. It's just,
I wanted to see if do you have a regulator in there that
No.
gets maximum energy out of the cap?
no. There's
Oh.
definitely not a switching regulator, because this thing, I felt anyway. Well, first of all, it's simpler to do it the way that Clint and I did it, but also, every power source, they're not all the same voltage. And I wanted to make this kind of universal. So it's just whatever voltage goes in is what comes out, and what the capacitor charges up to the input voltage. And when the input goes away, the capacitor, starts from that and slowly, or maybe not so slowly, discharges. But
Oh,
no,
okay.
there's no switching regulator to optimize the efficiency.
Okay. It just depends how much energy do you want to be able to get out of that cap?
Well, I don't know what Paul did, but on mine I have some 9 amp thermal fuses. They're the square things, the polyfuses. And I oopsed it and blew one of those fuses. Well, got it hot, so it did its job on those capacitors. So that's probably pushing the current limit, but I do know that it'll probably put out 5, 6, 8 amps for at least, do the math, a couple farads.
Okay. Well, what I'm getting at is, unlike a battery, a capacitor it has to lower its voltage in order to let any energy out, right?
Right.
So, how much of the capacity of the energy in the capacitor do you want to be able to get out before your load quits?
Well,
it won't be much.
Well, fortunately, we have 1/2 CV squared. So
Yeah, right.
the bigger the voltage, the way better off we are.
Well, yeah, but I mean,
Yeah.
how much voltage can your load tolerate before it quits?
So the B links we know from what Glenn says, they seem to run. They're normally powered at 19 volts. They will run down to 8 or 9 volts.
Oh yeah, okay. They already have a switching regulator. That's good.
Right. I mean,
I'm running mine off at 12, by the way, and this seems to work fine.
All this is supposed to do is just ride out a momentary interruption.
At Northern Utah, we discovered immediately when we put a B-link up there that even a normal UPS wasn't fast enough to make one of those the supplied brick ride through a glitch. It was like less than 100 milliseconds. They would, if they were under load, if they were running, full beans on all the cores, they would collapse immediately. And the worst thing is they would not recover gracefully. Since then, a friend of mine, WA7X, has replaced a bunch of his PCs at his house with these same, not the B-Links, but other NUCs. And he had exactly the same problem. But what he did was, and he even had a commercial UPS at his house. It wasn't nearly fast enough. What his approach was to use those, I don't know which brand exactly, like, but you see those power banks you take camping. Some of them will plug in the wall, but they have 12.
Yeah.
Those apparently are fast enough. So he was using those as point of load UPS, small point of load UPSs.
Okay, so I guess those little bricks don't have much, they can't store much energy in their high voltage capacitors after all.
Apparently not. I mean, at Northern Utah, we have the desktop computers with built-in supplies that, I mean, they run voltage doublers. If you're running them at 110 volts, they have what,
Yeah,
325, 350 volts.
that's how they could run on 240 volts.
Well, yeah. Well, they internally switch or something, or they have or modern
Wide range.
they have a
They have
power. Yeah, modern ones, they have the power factor correction circuit, which is essentially a boost regulator.
a boost regulator followed by a buck. Yeah, that's right.
Right.
Yeah,
And those, we know from experience, you can take those down to like 70 volts. And
yeah.
and if you're not running them anywhere near the ratings, they'll ride through. At some point, the power good line goes off. But the little bricks that come with these, the ones that they supply with the B-Links and whatnot are just terrible. I mean, they're just awful.
But
So
they don't have power factor regulation. I thought all new
not
supplies.
the cheap one. The ones, none of them that we have ever seen that come with the B-Links have power factor correction on them. The power factor on the one we checked was 0.45, which is worse than normal. Usually the cheap power supplies are like 0.55, but the mean wells that we got that I suggested to Rob, I tested those. Those are like 0.93, 0.95.
Does that mean more than what, 74 watts or whatever the requirement is in the EU?
I don't know, but the big thing,
we don't have that requirement here, but I know the EU has power factor requirements, but they kick in at like 75, which is why you see 74-watt Apple power supplies.
Right. But the biggie is, especially if you happen to be running on a UPS, if you have a power factor of say 0.5, you might think that, okay, I need to double the size of the UPS. Nope. You probably need to triple or quadruple it, because the peak current will shut down, will make a UPS really unhappy. And the peak current on something with a really terrible power factor on the crest factor, if you monitor it, that can be tens of amps on something that's only drawing, an amp or something average. And that peak current will really piss off some UPS.
I mean, what happens if you give them 240 volts?
Excuse me?
What happens if you give them 240 volts from a 240 volt UPS? It might be hard.
I suppose from an American standpoint, it'd be pretty inconvenient.
Yeah, but, well, I don't know. We all have 240 volts.
Right. Yeah. But yeah, and it's also, I know hams who have taken their inverter generators to like field day. First of all, you got an inverter generator, you're just asking for QRM most of the time.
Yeah.
The other time too is a lot of hams power switching portable power supplies are not power factor corrected either, like the Samlexes and all that. So they wonder why they can only pull like 600 watts out of a 2 kilowatt generator before the thing trips out.
Right.
That's exactly why. The cheap way around it, and it does work if you're willing to do it, is to put a super long extension cord on something with a terrible power factor. that does actually, that will get you a bit farther,
so to speak.
Yeah.
Okay. So anyway, I guess this is an argument. If I'm going to use Paul's little quote unquote UPS, it's an argument for using a 19-volt power supply instead of 12 volts.
Perhaps, yeah, I could see that. Although it should, I don't know what the runtime is. For the UPS, it only needs to run for, You know, if it ran for a quarter second at full load, you'd
Yeah.
be great.
But clearly, if the thing could handle the droop from 19 volts to 12 volts, that's a lot more than 12 volts to whatever it actually falls out at.
Right. Yeah. When we reset our B-Link remotely, we discovered that when it's if the B-Link is idle, 1 minute is not enough to do it on a 3 point whatever farad capacitor. So Paul uses half the capacitor he showed us half the value we used. Mainly, what we did is overkill. Now that we know, and the 1 point something farad is probably fine. But we know.
Yeah, I hope it's not underkill, but you know, we shouldn't need more than a
No,
10th of a second or something.
no, and I do know, that at Northern Utah, we did when we had the 888 running full beans, full decodes. We could unplug it for 1.5 seconds, like unplug and unplug it back in, and it wouldn't interrupt it. We didn't want to screw up the system while it was running.
Okay.
So we don't know how long it went. We think it could probably go for at least 5 seconds under full load with the three.
Oh, okay. That's because I'm thinking about the same thing you are. I'm working in the back of the rack. I got all this cable. It's in the wrong place. I want to move it, but do I need to shut the system down just to do
Right.
that? It would be really handy to have this next to the CPU for
Right.
that.
I mean, worst case, you stop the job, so it's sitting there at 3 watts, TPU, and then you can move the cable. Take 5 seconds to
Well,
do it, and move it
I
back.
always think I can move the cable in a second, and then oh damn, I didn't. I have to turn it around. It's polarized.
Well, I mean, there's that
The
old
wrong
joke.
place.
There's one of three possibilities that a USB cable can be plugged into. The
That's
first way you
right.
try it,
Right.
turn it over. The second way doesn't work. You turn it back, and it goes in.
Yeah, and if even with the USB-C connector, if you can't quite see it where you're doing
Yeah.
it, because it's behind the machine, you can't get in there. Oh God, I've been having so much of that lately. I hate SMA connectors with a passion now,
Yeah.
especially when you fasten the box in the wrong place. I've learned that tie wraps are much better than double-sided sticky foam because at least you can cut the tie wraps and move them easily.
On stuff that I use a lot, I bought rolls from Amazon of that double-sided Velcro crap.
Velcro, yeah, at least there you can lift it up and
Right.
reposition it. Yeah.
Yeah.
If the thing isn't too small.
Right. The problem I've noticed is the cheap double-sided stuff self-delaminate. So the hook side and the fuzzy side will eventually come apart after a while, but
Yeah.
it seems to be
Yeah.
glued together at the factory or something. I don't know what it is.
The problem with the double-sided sticky foam is it works too well. If you're going to put something down, you're never going to move it, then fine. But you
Well,
probably
double-sided sticky foam, in my experience, is one of those things that doesn't work worth a damn when you want it to, but works too well when you don't.
well, you
I mean, because I don't know how many pieces of equipment I've worked on where they use the double-sided sticky squares with zip ties on them, and those have all come off.
yeah,
I mean, of course, they will under tension and under temperature, but yeah.
yeah. Well, so if you get these when you buy your rack shelves, try to get them with ventilation slots
Oh
because they're
yes.
easier for, yeah. Problem is I have a couple that are solid, so that basically means having to use sticky stumping there to hold your
Well,
module.
one thing that I've done, like at Northern Utah, when we put our RF shelves together, I put thin plywood. I glued thin plywood to the rack shelf. Then I can screw stuff down.
Oh, that's an idea.
Yeah, I painted it black, spray rattle canned black, so it matched the metal. I mean, unless you did a double take, you wouldn't realize that everything's sitting on wood.
It does use up a little room, little
Yeah,
vertical.
I mean, but you get like 3/8 inch plywood or
Yeah,
something
and I'm
like
always
that.
putting the racks a little too close together, and I have it in. I got to get there in the matrix connection, and I can barely get my hand in there. Why did I do it so close together?
Well, yeah.
So I see Paul holding up some new parts.
Oh yeah.
Yeah, okay. You guys saw, I think, this little Ballon thing, and I have like 10 of these, maybe 20, I don't remember. And it's got the transformer, the cheap transformer with a low frequency, starts rolling off about 1 megahertz. And so I decided I'd have some more made, same footprint on the transformer, but this is using the what is it, mini circuits, whatever the transformer.
Have you swept an Ethernet PHY with the built-in magnetics to see how low they go?
Not with the built-in magnetics. No, all I've swept are just plain Ethernet. And I've done it with, anyway, so I got some of these with the transformer that has slightly better specs, common mode and low frequency. We'll see. I haven't, they just came in the same, they're waiting for me when I drove back up to my house an hour ago, along with this battery thing, or pardon me, the capacitor thing.
Well, how high do you need to go?
I'm planning on using these guys to run some of my distribute some of my other signals around my lab.
How high?
I swept, boy, I can find plots if you want to see what end to end looks like with short 4 inches of cable versus 100 feet of Cat 5 and Cat 6. Not much difference at all between the Cat 5 and Cat 6.
Well, what I'm getting at is that, I mean, Clint was just talking about Ethernet PHY. Well, the signals in both 100 and gigabit Ethernet are clocked at 125 megahertz. So they ought to go at least that high.
Well, and I've never met one that didn't actually work at 10 meg, but yeah, I've never actually swept an Ethernet PHY to see how good they are. I mean, they'd be a one device solution potentially to
Yeah. I mean, 10 megabit Ethernet is 10 megahertz Manchester, so that's basically a 10 megahertz carrier.
right.
And both 100 and a gigabit Ethernet use a 125 megahertz clock. So.
I have some Ethernet PHYs kicking around here. One of my projects was going to duplicate the thing that DX Engineering sells for an insane amount. Oh yeah, Scott says he's using an Ethernet transformer for his 10 mega reference for his 888.
Yeah.
But DX Engineering for 50, 60 bucks sells a doohickey that isolates Ethernet. And all it is 2 back-to-back PHYs in a box.
I mean, Ethernet already has isolation.
Well,
I mean, the spec.
Yes and no. Here's the problem I run across. If it has PoE on it, it is not balanced.
Oh, that's true. That's
the other
true.
thing too is a lot of devices are built the board as if it were to have as if it were to have Ethernet PoE on it, even if it's not connected. Which means, like for example, I have a switch here that does not have PoE. But what I discovered the hard way was that the PoE power supply is not installed, but the bypass capacitors and stuff on the wires they use for PoE are. Which means that RF on its chassis gets conducted out at all of its Ethernet cables. And I discovered that the hard way when, after I rewired, I have a Tesla Powerwall here. And after I rewired it for Ethernet, rather than using Wi-Fi, I keyed down on 40 meters and my house blinked on and off several times. Then I got a call from Tesla saying, we think something is wrong with your Powerwall. And I had to jump through hoops to convince them that I know what it is, it's not me. But I discovered then that even though it's not a PoE switch, you have to treat it as if it is, because it's the wires used on the Ethernet cable for the PoE are connected straight through, and they conduct RF all over the place. So I have, if you look at the cables, I have a number of chokes on them of various permutations.
Yeah,
I think I have 77, 75 mix chokes on them.
Right about PoE, I have a real problem with a couple access points radiating at around 80 meters. I think that's where their switchers operate.
Oh yeah.
If you're curious,
the switch is not the problem because it has a 48-volt power supply. So if you clean up that power supply, you're probably okay. It's the device itself.
Right. So we're looking at what the through loss.
You're looking at this is 0 to 100 megahertz. The scale is 1 dB per division. And the line on top is just basically a 4-inch stub Ethernet cable. And so you can see and this is two of these guys, well, back to back with, 4 inches of cable in between them. So, cut that attenuation in half if you're interested in just what one of them looks like. And then the two lower traces are Cat 5E, I think, and Cat 6 Ethernet cable. And actually the Cat 5 is slightly lower loss than the Cat 6. The Cat 6 has the, heavier wire, and it's got that spacer in the middle that keeps the pairs apart.
I'm not sure the
Here,
wire is heavier. I think the insulation is heavier.
the wire is heavier. It's a
Okay,
I
all
don't know,
right.
22 versus 24 gauge or something like that. I guarantee you
That
that at
sounds
least on
good.
my cable, yeah, I think it may not. You may be able to get Cat 6 with the same wire gauge, but the spools that I had were different. And then here I've got from 1 megahertz to 1 gigahertz. And let's see, it's 3 dB per division. So you can see and again, the Cat 5 and Cat 6 are the ones that are falling off, down to minus 24 dB, 27 dB at 1 gigahertz. And then the 4-inch, the upper trace, here we're seeing my construction and the transformer behavior. I'm sure the wire interconnecting is probably not relevant, probably not significant. So that's, what I got. I don't know, a bunch of
You're
other,
using one pair of a 4-pair
just
cable.
one pair. I'm
Which
using
pair?
the
Which
same
pair were you using?
for Glenn's antenna. He chose a particular one of the pairs. And so that's what this is connected
Well, it
to.
matters. It matters,
Yeah.
right? One pair is
on
special.
on Cat 6, the pairs have different twist ratios. And
Well,
Okay.
about the way
and-
the connectors are wired too.
Right. And the reason for the different twist ratios is to improve crosstalk, which at 1 gig and 10 gig is important.
And that's, look, I'm not testing this as Ethernet. This is strictly end-to-end. I haven't done common mode, which I plan to do. And again, that's going to be a transformer characteristic mostly. And I have not looked at the other pairs in the cable. Again, I'm using the same connections that Glenn is using for his antenna system. But for what it's worth, that's what I got. But I think I'm going to use for me, it's easier to cut pieces of Ethernet cable and put connectors on them than I don't have a huge roll of RG174 or anything, but I've got boxes and boxes of Ethernet from various projects.
Yeah, we all do.
So this might be a good way to run some of my reference clocks around and all that if I need to distribute my clock distribution even further.
As long as they don't leak. I mean,
Well, that's
the
going to be
main-
the common mode. And yeah, whether or not, how well balanced it is, I couldn't tell you.
Now, many years ago, I had need for transporting balanced signals. It was on Twinax, which is shielded, but still. But one of the things I needed was as much isolation as I could get. And I discovered, and I'm sure I'm not the only one that did this, is I could improve the common mode rejection of the transformer in two ways. One of them was to have a Faraday shielded primary and secondary, which is a luxury, but I don't know if you can buy stuff that way. The other thing is I actually ended up using balanced pots and balanced caps on the transformer. And I could, normally a box standard like T11, when you get up to like 30 meg, the longitudinal isolation is usually less than 30 dB. And I could get it over I could gain another 10, 15, maybe 20 dB, depending on the situation, if I tweaked those parameters. Had a pot, and I think it was like even a 10K pot was all I needed to balance out as much on the R side of things. then I ended up using a pair of small trimmer capacitors, and you only need one. You just need to figure out which side is the bad side. And I could,
So what, like a pot across the primary or secondary windings and the wiper going to ground or something like that?
something like that, yeah.
Yeah, okay.
I mean, the thing is if you go too far with this, you will compromise the total isolation. This was in a high lightning environment, but still, I mean, in other words, it had to stand off a kilovolt or two. But then Ethernet's rated what, 1.5 kilovolts is the official rating
Yeah.
for
Yeah,
Ethernet.
it's about
I
that.
think it's 1
Transformers,
kV.
transformers are rated for a kilovolt. I know that.
Right.
Right. So
I'm wondering if
That's all
Rob,
moot if it's PoE.
we were looking for you earlier, Rob. I didn't come. I think you're, yeah,
It's
you are
okay.
muted.
I've been, yeah, well, I've been taking care of business around the house, but, yeah, I'm fascinated. I think this is a great discussions on all the subjects, so I have nothing to contribute to it. But I did want to, Paul, I've, I wanted to talk to you as in your tapper role.
Okay, and Dave
Um,
is here as
And
well.
Dave, yeah. Um, I have just brought up a daisy site on St. Helena Island in the South Atlantic. And that was installed by Jerry Butler, G3GB or something. And he has access to a lot of sites in the South Atlantic and potentially into Antarctica at the British Antarctic and Australian Antarctic stations. So um, he funded and put this one up, but I thought it might be um, and he's interested in setting up and deploying both DAISY receive sites and whisper sondes at all of these islands. He's a traveling doctor and visits these places as part of his job. So so I'm wondering whether it might be appropriate to put this on these sites as part of the DAISY system and see if we couldn't ask ARDC if they would fund what would be, I think, not fairly modest, installation and maintenance operational costs for these. So I think to talk to ARDC, Nathaniel suggested that ARDC would have to, of course, provide the funds to a 501c3, and Nathaniel thought that TAPR might be a candidate. So I'm wondering if if first off, if you'd consider that, if TAPR would consider being the conduit for this. And of course, secondly, would ARDC be interested? Those also have to be, of course, established. But we're talking, $10,000-$20,000 total, I think.
that's much more doable than some we've already done. So,
I have to recuse myself in this discussion, of course.
yes.
Yeah, I understand.
And but we'd have to sit down and write the details out and then
Well, yeah,
but I
yeah,
think it's a very reasonable request, and I would think that
I mean, the science goal here was be to establish a chain of transmit and receive sites from the Antarctic through the Arctic.
yes,
And the sites like, of course, we already have DP0, but there'd be additional sites potentially if the British
yeah,
and Australians agree. Jerry has a contact on South Georgia Island, the Falklands. Now we have one installed in St. Helena. Ascension Island. John has EA7 BFK, so we could upgrade that site and maybe and then of course Europe, Scotland, Iceland, and we
yes.
have the Ellesmere Island. and perhaps we could find some others. So it seems like we could have a set of transmitters and receivers that would provide a unique view at one, longitude across
Is
the
there
whole latitudes.
receivers at Svalbard?
Uh, I think that there are, I think there may be, I saw that Roland was talking with some
Okay.
Norwegian researchers about putting one of his uh, whisper beacon stations up there. So there apparently are some hams who would be candidates. I haven't reached out to them because I haven't,
Nathaniel said the site, he had a research grant up there, and he worked in a ham station that was belonged to the educational
Mhm.
base there. So, and I have made content from my own QTH here to that
Oh.
station. So there may be an opportunity. The only issue is it may be an inconvenient spot, internationally. So,
I'm sorry, maybe, what do you mean?
well,
I'm sorry.
well, Svalbard has unclear ownership. Generally, the
Oh, I see.
Norwegians take care of it, but there's also a Russian base there as well,
Oh,
or there was.
oh. Well, I'm not, I don't, of course, don't want to get, we don't want to get involved in any politics these days,
No, we
especially.
really don't.
Just FYI, I think it is, the latest information I have is it's 100% Norwegian.
Okay.
Yes. Well,
Yeah, I mean,
well,
the
in any case,
Russians have
yeah,
pretty much abandoned, unless they've come back, they've really
Yes.
abandoned that site there.
yeah. Well, in
Yeah,
any case,
it was coal mining, and there's no Russian presence on the island
Okay.
except probably tourists.
Yeah.
well, we have, anyway, it seems like there's a project here, a unique, the 0 degree latitude, let me say, longitude, radio beacon and reception network for ionospheric studies that would pass through the South Atlantic anomaly. So it
Yes.
seems like it would be provide a really potentially really valuable, especially if we can also include the the timing data and use Paul and Scott's work. And
Yes.
so if you're amenable to it, Nathaniel proposed that we have a call with Jerry just to discuss this. So we're trying to arrange one for this week.
I think it's worth a call, and that we can
If any of you,
discuss the
if you would like
possibility.
to, if you're interested in participating, any of you, of course, in this group would be welcome to participate. Jerry had, and neither Jerry nor well, Nathaniel said that he would be better available later this week. Jerry is in Montana right now, so it would, be a normal daytime operating, probably Thursday or Friday of this week. So if you would, Dave, would you care to join? I mean, if this is, we're kind of proposing that TAPR be
Right.
the agency. And then, of course, we'd then have to come up with a proposal for ARDP.
Well, I'm the president, but also everything has to be passed through a board
Of course,
discussion
yeah,
as well.
yeah.
So I
Okay.
can't unilaterally do anything.
Rob, can you provide any way you can provide something for before what is it, next, not this coming Saturday, but next? I think Dave is our next
The fourth
board
Saturday,
meeting.
we have a board meeting every fourth Saturday of each month.
Yeah, it'd be nice to have something in hand so that we, and distribute it a little bit ahead of the meeting, so we can, have
I
a
mean,
useful discussion on it.
Okay.
I'm hugely in favor of it. And as far as whispersons, I've got like, I don't know, I have to look at my inventory. It's like 2 or 3 or maybe 4 or 5 even that don't have homes at the moment. And I can make more. Depending on schedule, I can make as many as we want. So, but
Yeah.
I could provide some fairly immediately for installation if
Yeah.
that was desired.
Well, it's a well, thank you both. I appreciate your
personally, I like the
interest.
idea, but I have to get everybody to agree.
Yeah. Well, I don't think it would, of course, it would not involve any uh, expenditures on your part.
Right.
We would hope that ARDC would be
Yes.
amenable to funding the project.
Well,
And
we are firmly behind the K9Q radio and the Whisper Demon project. So
well, well, that's good. The you can I think that this poor Jerry put in an i5 4570T, and it's really at its limits of what it can do. But I can actually show you the spectra if it's I put Ascension. Let's see, where is this? Is this I have to bring up the web page in a second. It's I'm in the middle of checking in code. Like every new installation, I encountered operating system library incompatibility problems, and I had to spend the day coding to make it work. Geez.
Dave,
So
I wonder, I might have just a second to bring up the 4-channel board here.
yes, of course.
yes.
Okay, where is it? Where is it? And there we go. Okay, can you see it?
Yes.
Okay, so this is, I just got the parts down and rat's nested today, so it still has a bunch of work to do, but this is the connector that the FX10 plugs into. And it's the Infineon USB 3 board, and you can see the silk screen to where it plugs in. There are 4 antenna connectors for each of the 4 channels, a pulse per second and a reference clock input, 16 bits of GPIO, and there's an external power connector because I can't get 5 volts from the USB board here easily. There may be a solution to that. The parts still have to move around, but essentially that's what the 4-channel unit looks like right now. All the parts are actually on the board in this area, but some of them pretty small. So that's where it is right now.
Very good.
Which ADC, Scott asks?
The ADC is a TI 4-channel part. It's a single IC with 4 RF channels up to 125 megasamples per second. And hang on, let me bring that up. They're 14-bit ADCs, but the parts cost, that part saves almost $400. And I can't seem to share it, so I'm not sure what's going on. Okay, well, it was sharing there for a while, but not anymore. Anyway, one of the parts is the 4-channel ADC, and one of the big parts is the synthesizer chip that puts out BPSK, different BPSK for each of the 4 channels, and that's synced to the 1 PPS input. So,
Looks like good work.
thank you. So back to the group.
Yeah.
Here's the receiver on St. Helena Island.
Oh,
As you can see, there's a lot of what looks like RF, but in fact, it's horrendous RFI below 4 megahertz. Nevertheless, above that, once you get up to 40 meters, it's pretty clean environment. And
Yes.
so if you zoom in, though you look at the what the low frequencies look like, you can see it's all garbage. I have no idea what the antenna is. I haven't so there's certainly dramatic, room for dramatic improvements.
Well, they're not
But
broadcast stations.
and oh yeah, there's just all kinds of broadcast stations there, and yeah, on St. Helena, the 7,000 people that live there are avid ham listeners. Let's see, this is what is the spacing? It's looks like it's about 50 kilohertz. No, that's 650 to 700. There's 50, so there's a 25 kilohertz. But
Yeah,
there's but there's a bunch of stuff. It's not just
I'm seeing displays like that so much now that I'm seeing them in my sleep.
well, anyway,
Dancing, well,
yeah.
harmonic.
So it's yeah. Well, those are anyway. This is
So what is
eh,
it typically?
what is this?
I mean,
This is
typically I mean, obviously it's a switching power supply of some kind, but
it's a common mode flowing through the circuit board from the through the ground plane of the of the
what's
ARC triple eight
generating? Generating.
is what's generating?
Yeah,
It's the
what's
ground currents and flowing through the neutral and the
from
probably.
where? From where? What's oscillating 50
Oh,
kilohertz?
who knows? Who knows? I don't know. It could be the PC, this little PC's power supply generating it. For all I know, I have no idea
What's
about this system. All I know
well,
is what I can see.
I
the
think
general rule of thumb is if it's a small power supply, it's going to be north of 50 kilohertz. If it's a bigger power supply, it'll be less than 30 or so. So that could very well be solar or something. And I would imagine they would have solar where they could on an island where you have to.
Yeah,
this is day
it's
or
got to be
night.
dark. It's dark there now, so it would have to be
This is real time.
Okay, that's true.
yeah. No, you might
PC power supply is the most likely.
They're,
I mean,
they're
on my
usually higher
PC,
though. I mean, 25 kilohertz is a bit low.
it's a bit low, yeah.
Yeah.
My one of my PCs, 500-watt power supply, is about 66, something like that.
Yeah, 50 to 60 is what most PCs I've seen
Yeah,
operate at.
awfully close to WWVB, in case you want.
Yes.
Anyway, just
Okay.
to
I
show
gotta
you,
run, guys.
yeah, it
I
is.
do-
It is.
I
It's
do
supposed to be.
too. Have to run. I'll leave
Oh,
everything running though.
okay.
That reminds me, last week, Rob, you wanted to talk about spur suppression.
Actually, I wanted to talk to Paul for a second.
Oh, sure.
Okay.
Paul, I'm planning to ship off a new B-Link to WWV0, right? To replace the Think Center there, which was challenged. And it would be a perfect place to put in your timing reference as an injector. So I'm wondering if I could get one of those here. So
Wait a minute. Timing reference.
your
What are we
burst, your
talking about?
burst, your burst, your little BPSK thing.
Oh. Yeah, well, let's trade some email about that. I've got some boards, but we need to decide exactly. If you just wanted to put out a constant BPSK, 1 hertz phase inversion rate, with no ID, no nothing, just driven from a Bodnar, we can do that now. If you want
That's what I want
something
to do. That's all I want.
okay, let's trade some email but
Yeah.
I can put something together for that.
My problem is I don't have a dual output Bogner, I don't think. So it's
Yeah, nor do I.
yeah.
I mean, that would be part of that's
Yeah.
the simplest arrangement.
Yeah.
Again, the dual baud now will provide the PPS and whatever carrier frequency, they want to run it on. But
Yeah.
again, if you're comfortable sending a BPSK carrier with no ID,
Yeah, well, it's going to be behind a low pass filter, so
Well,
so
wait a minute.
it's not
Oh,
going to
so
make
you're
it. It's
talking
not
about on the RX 888 injector. Okay, I'm sorry.
Yeah.
I thought in that case, yeah, you still need the dual Bodnar. Yeah, we're not. Then we just need to. Again, I've got this one here. Nobody's said they want it yet. Maybe this is it. We'd have to make sure that we agree on the filter and the level. I mean, I'll share what I've done so far, and I assume it's going to work on the 888 the way we're planning.
Well, Scott would be the person to. Right. He's. I thought
Yeah.
he had experience with it. But I thought you. I thought he had put it down.
He's got his own BPSK system. If Scott, if you're there, and if you want to try this out first before it gets sent to WWV0, that'd be great. I'd love to see it, actually tested in the real world.
That's
You'll
what.
tell me
That's
what to
what.
do.
Yeah.
So again,
Okay.
let's the three of us trade some email on
Okay.
when and where and how, but
Okay.
I'm
Okay.
more than happy to support this.
Well, it allows us to, validate this whole system, including your things, against the WWV
Yeah,
signals.
no, I'm again, I'm all for it. That's one of the very first steps. Um, test it against a local reference signal and see, what we can measure.
Well, I've been running Scott's wave monitoring mode, and that has been very stable. So, but it shows the offset, and the offset varies from one from one start of an AAA to the next. Radio D starts and it's our PCM record starts, and it doesn't know what exact time is. So there's an offset in the wave file. So the goal is to create wave files where
I got a comment on that too, by the way.
where the first samples of the wave file are at show the rising edge of the tone burst coming out of each second coming out of the WWV signal. That's the goal. I mean, probably only looking at it at once a minute, but right now you can see consistently once it fires up, there'll be, the tone burst will be offset by, I don't know, anywhere from 15 to 60 milliseconds. And
well, I mean, that's the whole point of this.
It stays that way the same, so the system is stable, but it's just not accurate. It's offset.
No, just need a calibration point, which this box or something like it would provide. Phil, what was your comment?
Comment on timing. Maybe Scott was trying to tell me this, but I finally realized or learned reading about in NTP some of the features in newer modern Ethernet controllers that allow you to timestamp the actual time the packets leave. And I'm thinking this has got to be useful somehow in precise timing on RTP packets. Maybe this is what you were trying to tell me, Scott. But it seems like it allows you to get down to like microsecond accuracy on the timings of some of these things.
You're talking about the hardware timestamping on the Mac and Phi with PTP?
Yeah.
Of course, it only does good if it's going on the wire. If it's on the local interface, it doesn't matter.
Yeah, that's right. If it's going on the wire, yeah.
Almost none of these systems are going across a wire. So it's
okay.
So it's just, and I mean, I don't, in our application, I don't think that that would be useful.
Okay.
Okay, well, as far as this box getting tested, I will send Rob and you, Scott,
yeah, great.
An update on, or just a description of what it is, how it's set up, what the levels are, just so you have a fresh copy of all that. But I can mail this thing to you tomorrow. Or maybe it'd be better for you to see what I send you an email, and again, a final check because once it leaves the door here, it's kind of hard to modify. Whereas if we decide we want to change frequency or levels, I can do that here pretty easily before I seal up the box and send it out.
What size are the attenuator resistors?
Oh, gee, I don't even remember. I've got numbers for what the output signal is. I sent that in an email, but I'd have to find it.
Okay, well, my only real concern is I don't have a dual output Bodnar, and so if I'm going to test it and need one, I'm going to have to get one on order stat.
Or something else that gives you a
Mhm.
PPS if you've got a
Yeah,
GPS with a PPS
I got
output.
I
Yep.
got to remember. I think I may have a dual output out at KFS, and I don't really need it. I need a signal output. I wish I had. I have two of Glenn's RE boards, but I can't get them to sync up,
Well,
and I just haven't wanted to. I just need some. I hate to spend, more money on Bogners. That's to be
okay,
honest.
well, here's an idea. With my spur suppression, it doesn't really matter much. Well, okay, this is a question I have. Would it be reasonable to switch to 10 megahertz on the R888, given that I can now suppress the 10 megahertz very narrowly? I could probably do it so narrowly, it wouldn't even take out the WWV carrier. And so if you already got a source of 10 megahertz somewhere, you wouldn't necessarily need a dedicated Bodnar to produce 27 megahertz or the PPS.
Well, you
We
need
need
the PPS,
PPS.
and
What's
you
that?
need a clock that's at the BPSK transmit frequency. So you
Yeah,
need.
well, okay. Is anybody having to generate 10 megahertz for stuff as I am?
I don't use 10
Oh, you're
megahertz.
not already, nobody's ever already transmitted. Never. Okay, all right, then never
I think
mind. I was
Scott runs
thinking,
at 10 megahertz, and I
Yes.
think
My units run it, the Whisper Sond and its cousins run at 10 megahertz
right.
reference frequency. They
Uh,
can run at others, but um, I'm running at 10 by default.
Okay, because I have a dual output binar. I'm using to generate 10 and 27. At the moment, I don't have anything that requires PPS, but I have another GPSDO that generates 10 megahertz and one PPS. Um, kind of needs a box to generate all three, don't we?
Well, what we need to work with this blue box here, the modulator, is a clock at the desired carrier frequency. And in this case, it's about 84 megahertz, because we're injecting it and above the Nyquist frequency. And so it needs a carrier frequency and it needs a PPS.
Well, don't you have that little box that generates multiple clock frequencies?
Yes,
The
I
product?
do. It doesn't
Yeah.
generate PPS though.
Oh, we
Scott,
can't divide down to 1 hertz though.
Scott, I could perhaps send you either the Bodnar in question or another I have a couple of these Tapper things that John Ackerman had, the pulse puppies that I use for, I think that's what I was using them for. Uh, uh, or I have, because I've got a number of sources of PPS. Uh, if, and I could just mail it down to you for a while.
Well, I've
uh,
got PPS sources. I've got multiple GPSDOs and U-blocks, but if
Uh-huh.
it's going to WWV0 station, we need to be able to test with the hardware we're going to ship the guy.
I see.
That's
Well,
kind of where I'm going at. If I need to buy a Bodnar, then that goes to WWV0. That's fine. I just, need to get it on order so that I can test with it, be sure we've got everything locked down
The,
before we send it to
I
him.
got it. Uh-huh. I
this
understand.
sounds like an ARDC tapper thing, ideally. I mean, we're all putting our own personal money into this because it's our hobby and we enjoy it. But at some point, $100 here, $100 there, it adds up.
My sense is Nathaniel uh, has funded the B-Link, which is, for WWV, the new B-Link. And so I gotta imagine he'd take the Daisy Grants money and apply it to Bogner for this. I mean, he's not here so can't really speak for him, but I guess
No,
we
he's
could
not
ask.
here to say no, so I guess we
Yeah,
can
yeah.
assume.
Well,
I'll
I guess
send it.
the question I
Yeah.
have then is, are there other cheaper GPSDOs to produce 10 megahertz and 1 PPS that you could use? Because I know BIDAR is a little pricey.
I wouldn't trust
Wouldn't trust
the
anything
cheap.
else?
I wouldn't trust the cheapo Chinese ones. I mean, we know now how the complexities of the
Well,
frequency
well,
You got a
setting.
bunch of them to choose from, though.
well. Here's a big difference. You don't really give a rat what the carrier frequency is, in terms of high stability. There's absolutely no reason in the world to have that 84 megahertz be nailed down. I mean,
You're okay.
so
So
I mean,
you
like for example,
Yeah, you want it close, but it doesn't have to be exact.
right, like for example, the the QRP Labs Prog Rock 2 is $18. It'll generate 3 frequencies at once if you wanted to, but it's half a part per million, which ought to be just fine for this.
It would
that's
be. But the
Yeah.
hardware we've got right now expects, a carrier on the SMA connector.
Well, yeah,
okay.
I mean, but I don't know if you ever used the Prog Rock 2. It had fit inside an HC6 crystal can. So, but it also is designed that you can let's see, can you? I think at least on one of the pins you could solder a SMA connector to it. But still, but then the 1 PPS is, I mean, have we determined that a cheap U box would be adequate for generating the 1 PPS? I mean,
I believe if we're shooting for, I believe we're shooting for roughly 1 microsecond accuracy here
right,
on this, not much better than that. So yeah, any of the cheap
right.
GPS chips is going to do that.
I do know that this here Bodnar isn't very good at generating 1 PPS that is absolutely nailed down. I
Yeah,
mean,
it doesn't even have an OCXO, right?
correct. But what's worse is if you take you can if you disable the output of the 2 output Bodnar like this, the output that is disabled produces 1 PPS. The problem is if you put it into a dual trace scope, I forget, it's either 8 or 16, every 8 or 16 seconds you see it step over and then it goes back. It's not.
What is the amount of phase jitter on that in terms of nanoseconds
Is
then?
that the new one?
But no, this is the new one. I've had this for about a year and a half now.
Oh,
I think there's a even newer one
The
that
picture looks
just
like
came
an
out
old
last.
one.
Yeah,
I think the new one's
one that,
USB-C.
yeah.
But again, how much variation are we talking about when it dithers the jitters on the output?
I'd have to look. I think it's not, put it this way. I know it's not better than a cheap U box I compared it to. So like for the eclipse in October and April a couple of years ago, I built I just used U box units and compared it to the Bodnar we had, and the Bodnar was actually worse, and it wasn't jitter. It's the fact that the 10 meg and the 1 PPS didn't seem to be synchronized with each other. And after it was some 2 to the n number of seconds, it'd fall. If you plot it out, it'd be a stair step. It'd go like this.
Yeah, no, it's probably like a internal 47
Right.
megahertz clock or something like that
Right.
Clint,
that's generating the PPS.
Yeah.
Yeah, if is the one you're talking about, the two output one, the one that's, they came out with a much smaller package, first for the single output, and then in the last 6 months or so, I believe, they came out with uh, a package.
Right. As I
No,
said, I've
smaller
had
than
this for
that,
It's
much smaller
smaller. It's
than.
the new one's smaller than that.
yeah.
I don't know if it's any better,
And it
but it's
claims
smaller.
they have on their website, they have a discussion of why it corrects. Um, s- uh, According to them, a known problem with the pulse per second behavior as I understood it. I never read it in great detail because I probably wouldn't have known what what they're saying, but it's a much smaller package than that. It's like a AirSpy,
Right.
uh,
Yeah,
you know.
but look, if it's even that, if the jitter's, on the order of 20 or 30 nanoseconds, which it would be if it were the, roughly 50 megahertz internal sample clock, um, I think that's kind of irrelevant for the purposes that we need here. That
Yeah.
much jitter is probably not going to affect the
Right.
time of flight measurements or the
But,
synchronization.
but I think this is kind of a prototype for something that would be, I think I would believe ought to be part of every DC installation. So if we're now requiring, in order to get DC installations to have, microsecond, absolute microsecond time accuracy of the wave files, uh, we're now talking about another Bogner when we don't really need one. What we need is we need, some crystal oscillator as a carrier to generate the carrier, and we need a PPS, which it seems like, I don't know, these cheap U-Blocks, I buy a U-Blocks module for
You know,
$10
I,
off of
I've
Amazon.
got a
It
I've got a
generates a
board.
PPS.
I've got a board that will do that right now. I mean, it's a prototype version of, a 3-channel beacon blaster. That's what I'm using to generate to work on my PRBS transmitting system. And, I could hold those, well within a microsecond accuracy just the way it is now. The problem is, even though the GPS chip is really cheap, I mean, it's like a $5 GPS chip. It's ridiculous. And it's more than good enough. But by the time I'm done building that board, you'd be probably cheaper to buy a Bodnar. Just because of what it takes to put the whole thing together. And,
Rob, didn't I
Maybe
loan you my
maybe it
Bodnar?
ought to,
Rob,
maybe
didn't I loan you my Bodnar a couple years ago?
yeah, you may, and it may be what's sitting out at KFS, I
No, no,
believe.
no. You returned it. I'm just wondering how well it worked.
Oh, well, I never checked the PPS,
Oh, okay. Because I'm
so
only
I
using
never an
Generate
indication.
1027.
But it seems though that the modulator part of it, the crystal for the modulator, ought to be part of your injector. I mean,
Yeah, I
if
agree.
if we can pick a frequency, that's fairly trivially easy to do. It's just at, when I was developing this,
yeah.
I had no idea what frequency we actually wanted. So I wanted to make it flexible enough to take anything.
There's one
And that's
other.
one of the reasons I think we need to get some, testing in the field to see whether or not our guesses are correct
Yeah.
as
So
to
I
what we
think
need.
the first one, if you, I mean, Phil, if you can lend us your Bogner again.
Well, I'm using it now.
Okay, well then that's not an option. Let me, I'll have to make a trip out to
But
KFS.
I can make measurements on it if you want.
Uh,
Clint, that dual
I-
Bodnar you were showing us, the dual output,
yeah,
you're using that at the moment?
No.
well,
Huh?
okay, given that I think that our ultimate solution will not be a dual Bogner, could we borrow yours, Clint?
I suppose. I was
What's your,
just about to As you can tell, I'm getting at my scope here, and I'm about to measure the difference between the amount of jitter that it has on the output.
Uh-huh.
Man,
Well, for
I
the
wish I could stick around, but I really do have to
Okay,
leave now.
that's okay,
But
Paul. Well,
send
we
me
can do
email or something, you know, I really want to follow up on all this.
Okay, thank you, Paul.
Yeah, you
It's
guys take care.
great. Okay,
thanks a
take care.
lot. Appreciate it.
Clint, what
It's,
model scope is that? I'm in the market for one. I got a scope that's literally an old CRT.
It's an ancient OWON.
Ancient, huh? Not as ancient
Well,
as my CRT scope.
no, I have a 465B over here that's even ancienter. And in the garage, I have some Tektronix 100 meg tube scopes.
Well, I used to lust after those things, and now they are so incredibly.
Yeah, well, one of those on in lieu of a space heater in the winter,
Yeah.
literally. And it's not an exaggeration.
I-
Those suckers have literally 100,
Oh,
110 tubes in them or something.
oh, this signal generator I borrowed is circa 2000. Man, the thing's like it's a vacuum cleaner when I turn it on. But it's
Yeah.
good. I'm using it. And I don't need it that often.
Right.
Even
Yeah.
even the A15 that I have is kind of noisy, though I turn it on only when I need it.
Yeah, my go-to signal generator is a Schlumberger service monitor communication test set, and it's nice because it's super stable. I've used it as a frequency reference at 10 gig by taking the bazillion harmonic. literally,
Oh,
literally, I've used one of these little easy hooks here, like these things.
yeah.
It clip it on a 1 in 914 on the end of a piece of coax, hang it in front of the waveguide, and turn it to like 900 some odd meg, and I can
There
hear
it is.
I can hear it.
Oh.
I can hear it at 10 gig on my
You don't
transmitter.
put a reference into the thing? I everything I
Yeah,
have takes a
yeah,
reference. I'll give it
yeah.
one.
I have a Hewlett Packard Z3801 over here. That's what 10 to the minus 11th, 10 to the minus 12th, or whatever they are. It just sits there and runs.
Oh, not the same as a GPSDO, is it?
It is a GPSDO,
Oh, it is GPSDO.
but
Okay.
it uses an 8011 oven.
Okay.
So it's capable of holding within less accuracy to better than a microsecond after 24 hours of no GPS.
Even better would be a GPS or Rubidium, but they're probably still rather pricey.
Well, I do have rubidiums.
I have a Rubidium too, but it's free running.
Yeah, my Z-Box, HP Z-Box is way more stable. That's what I use to set the rubidiums. But the rubidiums will take about 45 minutes ish to slip a full 360 degrees on 10 meg.
Yeah, I need to know how to adjust the rubidium I've got because I tweaked it without really knowing what I was doing, and now it's going to take me a long time, I think, to get it right.
Is it an L Pro or is it an Effertom?
It's an Effertum.
Oh, that's just a pot.
Yeah, it's a pot. Yeah.
Oh, okay.
I mean, what's the strategy for adjusting it though?
Oh, excuse me. I was going to say Effertom. Oh, well, okay. Well, I mean, just if do you have a GPSDO that is known?
Yeah, I do. I'm just saying how much time do I have to allow for the two? I mean, what kind of periods are we talking about for the
Tens of minutes.
Yeah, that's what I thought.
Right. My two GP.
And then I don't know how much to tweak the pot, so I'm going to first figure out what is the derivative.
If you did it, you would actually get the hang of it. Like I have an Efferton L Pro 101, and I also have an FEI 5860 or something like that. And the L Pro is a way better unit. It's so much better.
Okay,
and that has a C-field pot in it or whatever the.
Well, one thing I put into KNIQ radio some time back, you may or may not have noticed, is that when the PLL is on, it counts cycles.
Okay.
It counts total integrated phase. And I put it in just for this. And it will
Right.
also estimate, mean delta F over F to give you an idea of the parts per million. So my thinking is that I can just sync the radio to GPS and then listen to the rubidium, make sure it's nice and strong so it won't cycle slip, and then just walk away for a while and come back after some period of time and then say, okay, it's off this many this many degrees and this many minutes. Then I have to tweak the pot in the other direction. I need to know how much to tweak it, how long do I wait. I guess I can just do that and cut the difference and try to get it to zero.
Right.
But the measurement time you say should be like an hour.
Yeah. Well, to put it in perspective, my Alpro 101, which is, I forget, is that Effertom, I think. That one consists. I checked when I got it like 15 years ago, and when I brought it out for the eclipses, it was the same. It would take about 45 minutes for it to slip one whole cycle at 10 meg. The FEI takes between 20 and 40 minutes, depending on what mood it's in. So the Alpro
Okay.
101, which is the Effertom, I think, I'd have to grab it to see.
Well, what I'm getting at is that the Allen variance curves for the two clocks are going to be different.
Right.
In particular, my reference for my receiver is just a Bodnar, which I don't think has an ovenized crystal.
Oh,
So in the
oh,
short run, it may be worse, quite a bit worse.
okay. I was thinking that when you said yes, you had something like a HP 3801 Z box or something like that.
So no, I
But it's
mean,
a proper TCXO that had enough inertia that you could count on it hanging out at 10 to the minus 11th or better.
so yeah, the rubidium's got an OCXO in it. The Bodnar does not, but the Bodnar will be more accurate over a long period of time because it's slave to GPS when the rubidium is not. You see what I'm
Right,
getting at? The curves
right,
probably cross over.
right.
So I gotta wait long enough for the output of the Bodnar to be better than the rubidium,
Okay.
right?
I don't think you could use a Bodnar to set a rubidium.
Okay.
I don't think you could.
So I probably need to get a better GPS DO. I've been thinking about that anyway.
Right. I mean, if there's some way you could count the cycles over a day.
Oh, I can. I can. I
Okay. In
just
that
said
case,
my KNIQ radio has a
oh,
PLO
okay. You did
and
say
it
that.
counts degrees.
Okay.
Yeah,
If you could, is it possible to compare the two sources?
that's what I did it for. So you can compare the two sources.
Oh, okay.
It will count degrees. If you sync it to, let's say, a Bodnar, and then you put a rubidium on its input and you tune to 10 megahertz, you reset it, you turn on the PLL, you walk away, you come back, and it's going to tell you how many degrees off the rubidium now
Oh,
is to the Bodnar, right, over that period of time.
okay. I guess you could do it. I'd have. You probably know better off the top of your head how to do it, but if you had a whole day to do it, then I think on over a whole day, I think a Bodnar would be just fine.
Yeah, oh, exactly,
Right,
because the GPS is going to pull it in.
right. Okay, yeah, yeah.
But the fact that the Bodnar doesn't have an oven, it says that over the short term, it's probably going to be
Yeah,
worse.
okay. I'm with you now. Okay, yeah. I guess we're headed in the same direction, but
Yeah, that's what I
okay.
meant.
Yeah, okay. Yeah, yeah. Okay. Yeah, it sounds like you intended to do that, so you had to
Yeah,
try.
I just don't know how long do I have to? What are the recommended periods? Has anybody made an Allen variance measurement of a Bodnar on a GPS?
Let's see. KE5FX would be the first place I'd go.
KA5FX.
Kilo Echo 5 Fox X-ray. He's one of the main time nuts.
Here we go. John Miles.
Yes, you've heard that name, I'm sure.
No, I have not actually, but it
Yeah,
sounds like it's somebody worth looking
was
at.
was he the one in that Stephen Hawking PBS special that that he and his daughter dragged a whole literally?
No, that was what's his name in Seattle, who was not a ham at the time I heard him speak, but
Okay.
that was a while ago.
Tom,
Tom Van, yeah,
Tom Vander.
Dutchman. Yeah, a Dutch name.
Yeah,
Van Zant.
no, Van Bach.
Yeah, there we go. Tom Von
Yeah,
Bach.
yeah,
There we go. Yeah. Yeah. KE5FX or Tom, that guy. Uh,
yeah.
if anybody have done it out of curiosity, they have either one of those two websites. I remember has a very busy Allen variance chart of comparing a whole crap ton of different
Oh,
oscillators.
yeah. That's what I want to see. A whole bunch of
Right,
Albert plots. Yeah.
right, including the Bevatron or whatever the hell they were called. The crystal the crystal that the electrodes didn't actually touch. The made in
No.
France. They're the best crystal. They're the most stable crystal oscillators ever made, but they didn't make them for very long.
Oh,
I was talking to somebody about that a while ago, but it's essentially the quartz crystals in a vacuum, and they lightly couple capacitively to the resonator.
A solo quartz BVA.
BVA, there we go. Maybe it was you that I was talking to about that.
Yep.
Yeah, that's right. We that came up on discussion a couple months ago. That's right, BVA.
oh, here we go. He's done a BG7 TBL GPSDO. I have one of those.
They're not terrible, I understand. I mean,
If you get one that doesn't have the FLL bug.
well,
Well, I
Some
don't
are
know.
frequency locked, not phase locked.
right, but I guess that's when you get them, right? Or if yeah,
I know. I got one of the cheap ones. It has just the 10 megahertz to 1 PPS and an alarm light and not much else. Doesn't have a display.
okay, yeah, that's right. That's yeah, as I recall, yeah, I remember reading about that FLL bug. Also, it seems to me that along that class was what was it? GE Peter, the guy that invented PSK31, GE3 PLX,
Yeah.
E3 PLX. He he had a really simple quote GPSDO as well, and all it did was divided the 10 meg and down to 10 kilohertz. And there's a certain Motorola GPS receiver that you could also program its 1 PPS,
Jupiter.
but there's 10 kilohertz as well.
I think that was the Jupiter.
Was it the Jupiter?
I think so. I think Garmin used it in one of the old Earthmates because I had one.
Right. I have one of those here that somebody gave me,
Sandy
but
Miranda, Sandy Robinette, or one other.
yeah. But anyway, I
Well,
have
this
one of
looks
those here too.
this looks hopeful. The BG7 TBL GPSDO is equipped with a surplus Morion MV89A DOCXO capable of superb performance on its own.
Is
Well, that's heartening.
isn't the Morion the one that's in like a 16 pin dip header?
I don't know. I haven't opened it up.
Not the MV89. That's the top dog. It's huge. I've had one. I've cut it open.
Oh, okay.
It's a 5 megahertz rock that's doubled, and a lot
Oh,
of them had a broken surface mount cap on the outside board, so you didn't have to get in the oven to fix it. But they've all been China surplus, so it's like they use a blowtorch and a shovel to pull them off. You never know what you're going to get. But if you get a good one, they're very, very good.
okay.
Well, how do I tell if I've got a good one?
If it works. Well,
Well, it works. I mean,
the
Monitor
first
the loop.
well, I mean, I guess we're in that problem of man with two clocks does not know what time it is.
it says here the designer has chosen to use a very long loop time constant, several thousand seconds at least. It's quite a bit more stable at intervals between 1 and 10 seconds than the HP5071A that served as a master reference. Well, that's what I'm getting at. Over short periods of time, it's all about the crystals, not whatever is controlling the crystals, whether it's rubidium or GPS. It's all about the crystals over like a minute or less.
Right.
I mean that much I know. That's why I keep asking, what should be my strategy be for tweaking this? How long do I wait and integrate phase? Because whenever you do Allen variance measurements, it's all about comparing two clocks. There's no perfect reference. There's no back of the book you can look at, you know. All you can do is compare two clocks, both of which are imperfect.
Right. Well, I mean, based on all I can do, all I can tell you is based on the experience with the rubidiums I have, where you're talking about a 45-minute time frame, that would certainly
Yeah.
specify a minimum that you would have to wait.
Yeah, and those things take a long time to turn on too. I think they also have ovenized crystals because also rubidium is also producing a crystal output, right? I mean,
Uh,
everything's got crystals actually driving
but
the output.
all my rubidiums, both of them, well, three of them, with within about 4 minutes of power up, they don't move much.
Yeah,
I mean, so oh, what is it? The L Pro is really pretty good, but the which I think is an Evertom, but the FEI does have an outboard crystal oven that if it's cold, it takes a lot longer for it to warm up, and of course the problem, and of course the problem with it, as I discovered, was that if the temperature on that oven is varying, you get a phase shift because it seems to,
yeah,
because the PLL that it's using, I mean, it might be XOR gate for all I know, rather than a flip flop type. It varies depending on where that oven is. You get a phase shift. I don't know about the L Pro 101, which,
yeah.
but the other thing too about the FEI is that if I plug the L Pro 101 into my 10 and 24 gig transverters as a reference, it is fine. If I plug the naked FEI into it, I cannot tell which one of the dozens of carriers around my test frequency is the real one. It's the side are so god awful. So if you look on my blog or on my webpage, you notice I built a cleanup oscillator that goes on the FEI that locks to it, that just has a much lower time constant.
Yeah.
That makes it usable.
Okay, Scott, you're telling me you've been running your RX 888 in on 10 megahertz for some time, right?
Yes, since the
And you have no
beginning.
problems with that?
How would I know?
Well, I don't know. I mean, spontaneous failures, smoke coming out of the 888, stuff like that.
No, no, and I was scared of that. And when I bought it off eBay, I paid $30 for a 3-year warranty from the insurance company, and I'm kind of disappointed I've not been able to take advantage of it.
Yeah, well, well,
Well,
I don't know. It's
put it this way, Paul. So the official specs of the 3151 and 888 are 25 and 27 meg for the clock. But Paul in
I
his
think that's for a crystal oscillator.
right, right. But people, but you can, there's an Italian, a German, and a British guy, I think, who you can find on the web, where they decided to find out how far you could push a 53 or 51, both the Silicon Labs and the M-Star version. And you can about 1 meg is as low as you probably want to go.
Really? Yeah,
Right,
the spreadsheet actually says you can go down to at least 10 if it's
right,
an external reference and not a crystal. I think the
right.
25, 27 just has to do with the analog circuitry around the crystal.
Probably, and whatever, yeah. And then
Okay, so
apparently they've been able to push them up in north of 40, 50 meg too. But
okay. All right. So, all right. Well, the reason I ask this is because if I'm going to clock my HF station off of the rubidium, I'm going to have to do that because the rubidium only produces 10 megahertz. And I mean, the reason I've been hesitant to ever do that is because of QRM to WWV. But my notcher is working so well, I could just turn it on, pointed at 10 megahertz and have it suck out the reference while not sucking out WWV because there's too much phase noise in a WWV carrier for it to get sucked out.
oh,
This may
well,
be the solution to our problems.
well, the other thing too is they do have these single chip solutions that you put in frequency X and get out something times that, and it could even be fractional. Um,
What do you mean?
There are timing chips that are
Well, you
just
mean like a 5351, you mean? I know. Yeah.
Just chain them up.
right. But what I'm saying is, I mean, there's a DigiKey item. There's some chips you could get on DigiKey that you just strap the pins and you can get a dozen or so different multiples of whatever you put in.
Well, the only reason to do any of this is to try to keep the spurs down at 10 megahertz.
And 20 meg.
And 20 meg, because yeah, I mean there's a lot of second
Right,
harmonic.
right. But if you pick something like 2.5, well, that's a bad example. Like three times 30 megahertz, for example, if you multiplied by 3 with one of those rate generator chips, then you wouldn't be bothering anybody. But I take your point, it adds complexity.
Well, as complexity, what I'm getting at is I just want to remove spurs or limit, or, reduce spurs that are causing me trouble. But if as long as it's a synchronous signal and I can notch it out, then it's no longer a problem, is it?
I suppose, yeah.
No, it's not. I mean, my notch, I just picked a number out of thin air for what the averaging constant should be. And if you play with it, you've seen what happens, when it first turns on, you hear it, and then it kind of just fades away to nothingness over about 10 seconds. And that's such a narrow notch that WWV's carrier can't fall in it.
I wonder if that would be true at the WWV club station.
That's exactly what I'm wondering. And here, this brings up Michael Wan's problem with trying to separate WWV and WWVH carriers. It might actually be easiest to do it at WWV to pick up WWVH, because then it would be easier to notch out WWV. How do you like that?
That's a point.
Huh?
That's a point, yeah.
I never thought it might be easiest to receive WWVH at WWV. A 10 kilowatt transmitter right next door would actually make it easier.
Well, yeah. Although you do get ICPM on the modulation.
Yes, yeah. There's a lot of other crap that comes out of the transmitter, which is true. But it's an interesting thought. But anyway, when I did try it experimentally,